So welcome. Welcome to the very first webinar for the Undergraduate Field Experiences Research Network. We're really excited to have you all here, and we're going to get started right away so we could have plenty of time to hear from our speaker today. My name is Kari O'Connell, and I'm the principal investigator of the Undergraduate Field Experiences Research Network. It is an NSF-funded research coordination network project, and we're building an inclusive and open network that focuses on improving undergraduate field experiences. And we invited our first webinar speaker to help us launch this work. We'll be planning future webinars, dates to be decided, and they'll cover topics related to our project goals, which are these. We will, as I said, we're building an open, inclusive network. We would love for all of you to be involved if you're interested and hear thoughts and ideas. And we'll end our webinar today with a slide about ways that everyone can get involved and get more information. So before we get started, I just want to do a little discussion about some facilitation to make sure everything goes smoothly. So you should see in your session control bar a Q&A box. So if you have questions during the webinar, you should be able to type those in at any time. What we'll do is we'll have our speaker finish and then with some time at the end to do all the questions that people have. Another option for a way to communicate is you also should have a chat button. And you all are welcome as participants to share ideas and resources on the chat. And I certainly encourage you to do that. And we'll save the chat and post that along with the webinar on our website, so you can access those resources again. And like I said, we'll record the webinar and put it on our website. So now that we have some of that facilitation over with, I'm really pleased to introduce and welcome Dr. Susan Rundell-Singer to give our kickoff webinar. And just a little bit about Susan, she's currently the Vice President for Academic Affairs and Provost at Rollins College. And she pursues a career that integrates science and education, aiming to improve undergraduate education at scale. Her current NSF-funded research with Ann Austin at Michigan State focuses on networks of organizations working to improve undergraduate STEM education. Before this position at Rollins College, she was Division Director for Undergraduate Education at NSF and Lawrence McKinley Gould Professor in the Biology and Cognitive Science departments at Carleton, where she served for 30 years. She has been involved in an absolutely impressive array of national efforts, including chair of the AAAS Education Section and a member of the National Academy's Board on Science Education, where she was a participant in 6 National Academy studies, including chairing 2 of them. And she will be able to bring this national perspective to her presentation today. We are very pleased to have her as our kickoff speaker for the U-FERN webinar series and have her help launching the network. She will talk to us today about undergraduate field experiences, challenges, and opportunities.
Hi, everyone. I'm so excited to be part of the launching of a research coordination network. I found them to be incredibly valuable in terms of my own experience and look forward to where this network can go. What I'm hoping to do today is to give you a broad overview of the national landscape in which we're trying to improve STEM education with a focus on where we end up with undergrad research and field stations, marine laboratories. So I wanted to start out with, why are we all worried about improving STEM education? And I think, at 30,000 feet, it's because we face global grand challenges at an unprecedented scale. And it's going to take our collective expertise, wisdom, compassion, passion to address these collectively. And I was really excited to see in the National Academy's report on enhancing the value and sustainability of field stations and marine laboratories in the 21st century that one of the key recommendations was that we really have an opportunity here to bring together scientists from a whole range of disciplines, including our social scientists, to really begin to think about how to address these global challenges. And if we want our students to prepare to do this, we need to think about STEM education quite holistically, right? So one of the challenges is to build these T-shaped individuals where you have very deep disciplinary knowledge, right? I'm trained as a biologist, but I work with folks in all different kinds of disciplinary domains. And that takes a range of strong intra and interpersonal skills. I'll come back to that later, but I just wanted to highlight that there's another terrific report out of the National Academies on enhancing the science of team science. And if we're going to work across disciplinary boundaries, my mouse got a little ahead of me. If we're going to work across disciplinary boundaries, we really have some interesting challenges in developing individuals that are very good in working in teams. So I'm going to start not looking back. We'll do that in a few minutes, but I want to look ahead, because if we're preparing students, we need to think about who our students are going to be in the next decade and make sure we're ready for those students. So during the recession, we had a 13% reduction in birth rate. So 10 years from now, there's going to be a smaller population of students going to college. And my colleague at Carleton College, Nathan Graw, has done a really interesting study looking at the demand for higher education. And the salient point in his analysis is that not all high school age students are equally likely to go to college, and they're not equally likely to go to the same types of college. So if you're in one demographic with well-educated parents, with very high income level, there's a 95% probability that you'll go to a four-year college, and actually a 70% probability of attending a top 50 college or university. For a member of another underrepresented group with a single parent and a lower family income, there's less than a 10% chance of going to a four-year college and about a 2% probability of going to a top 50 college or university. And that really, for me, gets me thinking about all this talent, potential talent in STEM, and how do we become more inclusive and bring people in? Because we're going to need everybody to solve these problems. So one of the interesting things that Nathan did in his study was he mapped different regions of the country and said between 2012 and 29, what's going to happen in terms of the size of the population of students going to college of different kinds. So red is a decrease that's going to be, like a 15% or more decrease in the student population. And on the blue end of the spectrum, greater than a 7.5% increase. So red means there just aren't going to be students going to college. And you can see the patterns differ in terms of who's going to a 2-year or regional, national, or elite 4-year school. What's compelling about Nathan's work is he built a model and said, okay, what if we then, and this is on the left-hand map here, what if we halved the effect that income was having on who goes to college? And then over here, what if we halved the effect that race and ethnicity are having? Remember, blue is terrific in terms of more people going to college. Red, not so happy. And this is a model looking at national and elite four-year schools. So if we could begin to address income and race, we could greatly increase access to college and access to great minds that could help us solve major challenges. The National Academy's report on barriers and opportunities to 2- and 4-year degrees unpacks this challenge. And now I'm shifting from a prospective analysis to how we got to where we are and why attending to this broad demographic is a compelling challenge. So I wanted to start first on the left-hand side here. This is the plot that goes from 1965 up to about 2015. And it's looking at the percent of individuals who attain a bachelor's degree by the time they're 24 as a function of their family income, so their socioeconomic status. So the top line here in blue, this is for the upper quartile of socioeconomic status, right? And we've pretty much doubled degree earning in a generation. We've gone from 40% to 77%. If we look down here at the purple line, these are students coming from the lowest quartile of socioeconomic status. And we've seen a 6% to a 9% increase in bachelor's degree attainment. So we've functionally doubled the gap in college attainment between lower and higher income earning families in a single generation. And there are a lot of reasons for that, and they're worth thinking about, they're worth doing further research on, but we make a lot of assumptions beyond family income, and the Barriers and Opportunities study outlines that, right? So one is this pervasive belief that certain people have natural abilities and that ethnicity determines success. We have very complex pathways to completing degrees, and STEM degrees can be more expensive. And I think when we think about field experiences, right, that costs a little bit more. How do we make sure everyone has access? And we have a hard time capturing data in this country when people swirl through community colleges, and that affects specifically these low income earners. Now, one of the common responses is, well, by the time we get to college, it's been a K-12 challenge. Depending on where you live, you've had different access, different opportunities, and you just aren't ready to go. And I think there are a lot of reasons to push back on that argument a little and say we need to teach the students that come to our colleges. And to do that, the data I wanted to show you here looks only at students who scored in the top quartile on SAT scores or ACT adjusted for an SAT-like score as a function of socioeconomic status. So what we're going to do here is look in this set of bar graphs at the students that went on to college, to a four-year college as a function of family income. So darkest bar, highest quartile, SES, 80% of those students go to college. Only 44% of the lowest quartile go to a four-year school. These are equally academically capable students based on standardized test scores. The differentiating factor is family income. And here, who doesn't go to college? Only 6% of very talented young people from economically privileged families versus a third of the students from less economically able students' families. So you can see again how we get this gap in college degrees over time. Intersection between degree and gender matters also. So income, gender, and we'll get to race in a second. This is some data from Tona Carnevale's shop at Georgetown. And, you know, it's kind of startling, right? Men with some college, but no degree earn about the same as a woman with bachelor's degrees. And women have to have a PhD to make as much as a man with a bachelor's degree. When you begin to unpack it, right, it's not that we're just paying women less for equal work. It's that women are getting degrees in different fields. We continue to have fewer women getting degrees in engineering and in computer science, which tend to be higher income generating occupations. And the same plays out with race. So despite the increase in college attendance by African Americans, the income barrier correlates with fields that people are choosing. And I want to be very careful, right, that we should all choose fields of study and work that align with our passion. But when someone aspires to something and the doors to that pathway are closed to them, that's a different case. So let me give you a few examples and remind you that African Americans compose about 12% of our population. Only 3% major in agricultural and natural resources fields. And I think that's particularly telling for those of us that are passionate about field work. And you can see the numbers are also low for a number of other fields in STEM, including only 7% in biology and life sciences. So how did we get to this point? Lots and lots of reasons. And you can see so far, I've been trying to make a compelling case for why we want to improve STEM education. But what U-FERN is all about is using evidence to improve STEM education. And we're slowly getting to the point where we're making evidence-based improvements, but it's been a long time in coming. So I'm going to give a brief case study with biology. So not that long ago, actually 1887, we biologists were trying to make the case that biology should be a field of study in higher education, right? That it would be possible to major in biology. And I'm going to jump forward to 1958 for a couple of reasons. The post-Sputnik era really stimulated a lot of interest in improving education, but not necessarily understanding and doing the research on what is leading to that improvement. So the biological sciences curriculum study, which exists today and literally changed the way we teach biology as a more inquiry-driven field of study, started then. And we'll come back to it, but that's when NSF first started funding undergraduate research. By the mid-90s, a whole coalition of professional societies in the life sciences, there's around 147 different life science societies just in our country, came together to try to press on improving life science education. And you begin to see professional societies developing education committees that become more active and vibrant. Where it really scaled was in the 2000s with the Vision and Change effort in undergraduate biology education, funded and supported over time by the National Science Foundation, the Howard Hughes Medical Institute, the National Institutes of Health. This next figure, is not for you to necessarily spend a lot of time looking at, but I hope it will inspire you as you start U-FERN as a network to think about and this is about a 10-year period, when a group of individuals nationally come together and decide they're going to drive change in an area. In this case, it's how we teach undergraduate biology. A lot of things happen, and more importantly, a lot of things begin to stick. So that's a really interesting model you might want to come back and reflect on and think big and be ambitious for U-FERN. So there was a lot of change in undergraduate biology education. And if I stopped with my last two slides, I would leave you believing perhaps that it was just the collective will of a group of passionate people. I think that's true, but I think there's more to the story than that. So there were a lot of other factors that were driving change at the time. So biology education was getting pressured to shift from being a descriptive field of study to being a data-driven, very analytic field of study. So this National Academy's report several years ago now on a new biology for the 21st century argues that a typical biologist may actually not even be a biologist, but could be a physicist or a computer scientist. You saw in the FSML report the reference to convergence. That's another way of thinking about all these fields working together. That came out of the Nanobiotech Initiative at NSF. Then Susan Huckfield and Phil Sharp at the MIT pushed this quite hard with a National Academy study. Convergence is now one of the priorities at the National Academy of Science, but also the National Science Foundation. We see a lot of data-intensive work in environmental studies and genomics. It's moving into education. MOOCs and large-scale data generated from online learning provide us with a robust source of data. I'm certainly not arguing that we do field experience online, but we have opportunities to learn about learning from larger scale data sets. And we also saw the emergence of a field called DBER, Discipline-Based Education Research. This particular report was released in 2012, and it's actually the first time there was a synthesis of what we know based on evidence about learning in undergraduate science and engineering. 2012, a little surprising, right? So DBER looks at learning really deeply embedded in the priorities of a discipline. It's complementary to and integrates a lot of other fields of learning. What's interesting about the DBER work and a report that came out of the President's Council of Advisors on Science and Technology called Engage to Excel is how the research has driven policy and funding, and I think created a really rich opportunity space for the work and the research agenda U-FERN may imagine. And you can see in my blue box here on the right that I'm, calling out that there was really terrific pressure to improve laboratory learning and more discovery-based research. That led to a 2013 release of the first ever federal STEM education 5-year strategic plan. At the undergrad level, the push on research was in there, but it's also present in all the other groups, including informal science education. So I think that's a interesting and important opportunity space for all of you in U-FERN. So why is the research piece so important? It's one of the high impact practices associated with student success. On the left side of the screen here, I'm sharing with you a couple reports out of the American Association of Colleges and Universities and some work by George Koo showing that these practices like research are associated with student success. There's just to be provocative, a paper that I listed down in the bottom that came out last week, challenging some of that research in terms of its impact on graduation rates. And I think that's worth thinking about. My first blush interpretation is that it's not enough to just say, I had a research experience. It's understanding what that experience looked like. There's also the Gallup-Purdue work that came out in 2014 on experiential learning and support, and the kinds of experiences undergraduates report that make a difference in their lifelong well-being, so financial well-being, health, their satisfaction with their work. And if you look through those, I won't read them to you, but you'll see that there are many elements in there that are really reinforced by a first-rate research experience. So in the FSML report, there is a call for field stations to really begin to understand how to engage students in collaborative research, in active learning, because it will increase interest and persistence. So again, this report is very well aligned with a lot of other national calls for action that are evidence-based. So what do we know about undergrad research? And, you know, as I go through this, I'd like all of you to just pause and think about your early research experiences, if you had them. What impact did it have on you? My whole professional life has been shaped by research experiences, beginning with a high school research experience at a medical college and undergraduate research. So I'm asking you to check into some of those memories, because we also have tied to that a lot of assumptions and passion. We actually, I think if we have shared beliefs about this, it goes back 200 years to Berlin, to Humboldt's idea of unified teaching and research, first discussed in 1810. I happened to go to Rensselaer Polytechnic Institute, the oldest engineering school in the country, started in 1824. And what's fascinating about the curriculum that Amos Eaton started there was it was totally integrated research and teaching. Students did experiments 6 hours a day, and they lectured rather than being lectured at about their findings, and were quizzed. And as early as 1927, there was a prize for the best undergraduate research dissertation established by graduates of the class of 1902. So very, very long history there in terms of marine stations, field stations, right? There's a very long history. I believe one of the oldest experiences is at Woods Hole Marine Biological Lab. The embryology course started in 1893 and has run every single summer since then, a really deep research immersion. And what I'd like to move into briefly is this is not just good in terms of education, it also contributes to research. So think about your introductory biology course, or even high school in genetics. Calvin Bridges and Alfred Sturtevant made groundbreaking genetics discoveries that our students still learn about. They were undergraduates at Columbia. So students engage in research to learn and to contribute. The National Science Foundation since 1958 has funded research experiences. Originally, this was the Undergraduate Research Participation Program, launched in 58. In 1981, which was actually the year I graduated from college, so it's really kind of poignant for me, was zeroed out in President Reagan's budget request to Congress. In 1987, it was reinstituted and has continued since then as the Research Experience Program for undergraduates. I was at Carleton by that time and managed to have 7 site awards for undergraduates doing research. And I bet many of you have either benefited from experiences or learned from them. And when I was at NSF, the division I was in, the Division of Undergraduate Education, we coordinated the program across all of the directorates, but each of the directorates managed their own REU funds. And it's interesting to think about as you think about integrated approaches to research within that structure, how you get the more cross-cutting efforts in place. So let's go back to evidence, right? So I challenge you to think about what you believe about research. Undergrad research is at the heart of everything I've done for 32 years, right? I've had 140 undergraduate research students. I've managed REU sites. I believe in REU. So I actually started on that jaunt with a bit of evidence, but a very little bit. And I want to challenge all of us that there's so much more we need to learn. I actually started at Carleton College in 1986, and Bob Edwards was the president at the time. And he had led a study called the Oberlin Study. This New York Times article that I cite describes this, but the top 50 liberal arts colleges in the country went in and looked at some interesting data at NSF and found that a disproportionate number of students getting their undergraduate degrees at these small liberal arts colleges went on and got PhDs and were disproportionately per capita contributing to the professoriate. And as they looked at the data, their conclusion was that it was because so many of these students have really deep research experiences as undergraduates. And it turns out that's really important at a small school because you don't have graduate students. You want to get your research done. So it's easier, or there's greater necessity for those undergrad research students to be true research collaborators. This has grown far, far beyond the undergraduate colleges in the course of my career. But I think it's interesting to see that study. And it's also interesting that that study, and I went back in and looked at some of the archives, actually drove the return of the funding for research experiences at NSF. And again, to the point that it's not just valuable educationally, there's this 2017 study that shows we've really undervalued the contribution that undergraduate researchers make to advancing knowledge. So where are we? There are about 500 RU sites running every year, about 5,000 undergrads. There are supplements for folks that have research grants, another about 3,500 students. Varies from budget year to budget year, but about, somewhere around 80 million getting invested in this. And there are lots of other places that fund undergrad research, to be very clear. But they do really great things, right? And I'm not going to go through this whole list, but this is a set of characteristics of high quality experiences for undergraduate research students in a traditional apprentice style model, and they participate in the full spectrum of research. The challenge is that we have about 5,000 institutions of higher education in this country, and some of them have tens of thousands of students. With the funding models we have, say you took just NSF and acknowledging there are lots of other sources of funding, but you can maybe reach 10,000 undergraduates each summer. You're not going to reach all the students that could benefit. So one of the newer models that's emerging is to integrate research into the course experience. This National Academy's Convocation Report gives a broad overview of the work that's happening in that arena. And there are all kinds of course-based research projects. Howard Hughes Medical Institute has funded the CFAGE program for introductory biology for a long time. On the right, 2 papers that have come out of fly-based genetics consortiums. Some have over 1,000 students authoring a paper in Nature. I mean, it's pretty exciting to see what students are collectively doing. CureNet is another RCN that pulls these experiences together. Aaron Dolan has provided leadership on that. And then I included a collaboration of small colleges that I participated in where we didn't all work on the same project, but we all figured out how to help people bring genomics approaches into the model and the system they were working on. So they brought their research expertise into the classroom, but there was a common thread and a sharing opportunity. So different ways consortia can work together. And so that really leads us to a range of research opportunities. These are, students in my former lab at Carleton, but, there's research in a course context. There's independent research during the academic year. There's 10-week summer experiences, and they have varying degrees of structure and scalability that can serve different functions, but it's a way to reach more students. And again, you can learn about learning in those situations, right? You can do research on learning, you can improve education, and you can contribute to advancing knowledge in your field. So this is just from the project that I did over time with my students at Carleton. I also think we need to be really curious about what other folks are doing, what we can learn from them. The Science Education Resource Center at Carleton, Kathy Manduca's shop, has pulled together a national community of scholars that work in improving geology education, which is almost entirely field-based. So I did a few screen captures from the website, but if you're looking for really high-quality, peer-reviewed material on different approaches to enhancing learning in the field, there's some great resources there. And then we want to kind of pull things together towards the end of some work that my team and I did while I was at NSF, really wanting to push the research agenda to understand what we need to know about undergraduate research. We commissioned and funded the National Academy of Science to do a study on the multiple dimensions of undergraduate research experiences for STEM students. And I'd really encourage your group to take a look at the report. You can see from this list that there's a whole range of research experiences, not just the traditional approach. And the beauty of the report is they identified what key elements go into a high quality experience. Again, because you can go back and look at the slides, I'm not going to work through each of these. I will point out that, as I started early on, opportunity for teamwork, which again, from the FSML study, as you work across disciplines, very important. And the last one is the importance of a mentor, and we really need to learn more about mentoring. So we know that you can increase graduation and retention rates in STEM, especially for underrepresented groups. Data from the University of Michigan tracked since 1988. Things like increasing sense of belonging, and this is a nod to the Supporting Students College Success, another study at the academies we commissioned. But you can see there are a range of interpersonal skills that can be enhanced. But what's troubling is so much of what we know about undergraduate learning has yet to be applied to these research experiences. Somehow they've gone down parallel tracks. And I think, again, U-FERN has an opportunity to bring those together in terms of mentoring. You might want to follow, there's a newly launched study at the National Academies on mentoring. So it's just getting launched, but that may give us additional guidance on how to provide professional development for mentors rather than just say, go do it. The College Success Report is a really valuable one, looking at assessments and what we know works in terms of supporting students' college success and lifelong well-being, sense of belonging, growth mindset. If I work hard, I can get better at X versus I'm not good at math, or I'm great at math. And utility goals and values that I see this work is going to get me to where I want to go with my life. And then there's moderate data supporting their interventions and success in some of these other areas as well. But it's wide open. Field stations are a great place because it's such an intense wraparound experience to explore some of these areas as well as cognitive games. And we have a lot of research gaps that one could look at there, right? So the link between interpersonal competencies, teamwork and college success or lifelong success, competencies in community college students, we don't know as much about, mostly four-year students. And very, very little work has been done tied specifically to STEM. It's been much more generic. So are these things particularly effective in STEM, differentially effective? We don't know the answers to that, especially interpersonal competencies. And again, field stations are a great place to explore those questions. And gosh, we need some really innovative assessments. So let me just step back, right? I started talking about the national scale and changes there, I want to come back and challenge us to think about how we might know long-term beyond the specific work we're doing, because U-FERN is a national network. How might we be collectively improving STEM education? So the third report that my team commissioned from the National Academies was to develop a national indicator system. And there were 3 goals in that, and collectively everything together was looking at the progress of our nation, not of any one institution alone, but the nation as a whole. So cognitive gains for students, equity, diversity, and inclusion, and then actually having enough STEM professionals to meet our workforce needs. And those are disciplines specific within STEM fields, of course. So there's a whole framework that's kind of interesting to think about. And I offer the framework because as your network is moving forward, this isn't your framework, but the idea that a framework in terms of what you're putting in, what the environment that you're working in, what the educational processes are that are involved, and what the outcomes are, is a very helpful way to frame things. And we actually had not done that for STEM education at a national level, and I think this is a useful model. And again, you know, a national level is different than what we might do in an individual course study or an institution study, right? We can't go assess the learning of every student in the United States. That's just not the way forward. But we can find ways to measure whether or not we're using effective teaching practices. And so this slide just gives you, again, a way of thinking, whatever scale you're trying to do your assessment on, you know, how can you get indicators that are actually plausible and possible at that level? So I'm going to leave you with these thoughts. There's lots of information, but I think the opportunity space, right? Deeber started in looking at cognitive learning, but there's a much broader set of questions we can ask, and I think you can be part of this Deeber 2.0 generation. We need to look at a cross-section of competencies. We need to look at equity and inclusion, and that's why I spent quite a bit of time at the beginning of this webinar trying to help you understand from my perspective why I think that's incredibly important for all sorts of reasons. And then thinking about how do we really get systems level change and how do we measure that change. So I think we end with the FSML report and E.O. Wilson's inspiring convergence type of quote, but more importantly, field stations will serve as key centers for education at all levels. I would amend that to field stations will serve as key centers for education research at all levels. And let me stop there and turn this back over to Kari. Should you have questions, some conversation might be in store also. Thanks for your time. I've got to stop sharing my screen. Now it's back to Kari.
Yeah, that's great. Susan, thank you so much. That was really inspiring and really informative, and we clearly have a lot of work to do, but super exciting to think about how we can all do that together. I know you can't see everyone, but I'm sure we're all clapping for the great presentation you gave us. So I've been tracking, and we actually don't have any. Oh, yes. And I see that people are saying in the chat, clap, clap.
Thank you, Sean Anderson.
Yeah. So I encourage everyone to use the Q&A button to start typing in a few questions for Susan. So we'll do the virtual parallel of giving everyone a minute to think and give us some questions to think about. And while we're giving everyone a few minutes, I'm going to actually go back to my presentation for that people, this. that people can see ways to get involved with U-FERN while we're answering some questions. So I'm just going to read these questions for Susan, and we'll get through as many as we can before the end of the hour. And then Susan has offered for anything that's left unanswered that we'll try to provide some answers up on our website. So the first question, and forgive me if I mispronounce names, Trina Kilty asked, how do you think field studies and research experience for undergraduates might play out at community colleges, where courses typically don't go beyond introductory, as in no majors yet?
So I can steer you to a really interesting network of community colleges. They call themselves CCURI, the Community College Undergraduate Research Initiative. Finger Lakes Community College in New York State is kind of the hub, but it's national. And if you look at the website for the Council on Undergraduate Research, which is mentioned here in the slide that Kari has up, you will see that they have a publication out on doing undergraduate research at community colleges. And they have all sorts of tools for community colleges to assess readiness to engage in undergrad research. A lot of it starts as course-based research. One of the takeaways that I find really compelling from their work is they did it as a research study as well as actually doing and continuing to do great research with their students, was that you have to have a team, right? And I think so often any one of us has a great idea and we go home and we want to make that happen. I've been guilty of this too, rather than getting other colleagues that are also excited and all of you doing it together so that the effort is sustained if you move on or you take a leave or you're doing other things.
Thank you, Susan. So we're getting a few more questions. The next one, Kumar Das asked, she says, or they say, thanks for your presentation, Susan. I direct the Office of Undergraduate Research at Lamar University. How do you encourage faculty to get involved in mentoring undergraduate students?
So, one of the things that we have here at Rollins College, Kumar, that might be interesting, we have something called the Student Faculty Collaborative Research Initiative, and different faculty member coordinates it for several years. We have endowed funds for it, and I've been working hard since I came to Rollins to help us increase that endowment. But it's a very prestigious opportunity for students to apply to work with a faculty mentor. They work with the mentor to develop the proposal, and then there's funds for the mentor, for the student, and for supplies. And it's a fairly large group of people that receive these each summer. There are weekly meetings. The students give presentations to each other. It's not so different than an REU Site Award, except it's internally funded. And again, my prior institution did a brilliant job of raising endowed funds and having the continuity there. So building this culture, but with the supports for the faculty and the incentive for them to include the undergraduates has helped a lot.
Thank you, Susan. We actually have a question from Sean Anderson on chat, which I'll read to you.
Okay.
And he says, I have a quick question. We do tons of research within our classes, but so often we are out in the wilderness in terms of funding. I'm wondering about support specifically to document the efficacy of these modalities.
So Sean, when I was at NSF, we went through and sorted all of the funded work at the time to see if there, what was happening in terms of course-based research. And, I think that you would find that the Division of Undergraduate Education at the National Science Foundation, especially the IU's program, Improving Undergraduate STEM Education, is a place where you could come up with an innovative idea for doing this field-based research with your students and learning from that, right? Because you want to build on existing knowledge and you want to generate new knowledge in these types of programs. But I would take a look at that program. I don't know what field you're in, but I know Dave Moak, who was at Montana, and I believe he's recently retired, but I think, he's published. You can find out about him on the CERC site that I mentioned as well. His research over a number of years was with his students in the field, so out doing, wonderful geology work in the Rockies, but understanding and doing research on the students while they were doing research.
Thank you, Susan. So we have a couple more questions. Graciela La Cueva asks, are there opportunities for students in physics or other non-life sciences majors to participate in field experiences in biology?
I think that, anyone who applies and can make a strong case would be given serious consideration. And what's really interesting is as we shift from thinking about undergraduate researchers as being, almost grad students that work with us to help generate data, to also think about it being a learning experience. There's a lot of evidence that engaging students in the first 2 years of college and research experiences, especially for traditionally underrepresented groups, is very likely to enhance their persistence in college. And often in the first 2 years, you may not have even declared a major, right? You're not necessarily biology or physics, but I have loved having physicists, computer scientists, mathematicians on my research teams over the years. My current research project, I actually have a student who's working on an MBA in business working with me. And my prediction is, as research becomes increasingly convergent, we're going to need to build those interdisciplinary teams.
Thanks, Susan. A couple more that I think we can definitely squeeze in. Janet Branshaw asked, the idea that we need to focus on measuring how we're teaching, e.g. evidence-based instructional practices, rather than student learning assessment at the national level to measure systemic change is very interesting. Can you comment on how you see assessment of student learning contributing to the effort? Specifically, how should we be supporting those who are teaching to learn about and use rigorous learning assessments to guide their teaching?
Okay, so yeah, thanks, Jess. If I came across with that message in any kind of dichotomy, let me put that to rest. I think we need to look at all dimensions of learning. And actually, I think the biggest concern I have is that, if we just say we're all doing active learning, everything should be fine, it probably won't be fine at all. At the end of the day, we want to understand that whatever we're doing helps students learn. So a lot of the strategies that have come out of the Deber work that show increased learning are actually studies done with a very limited pool of students. And we don't know how that might work in another context. I think these network improvement communities like the Statway Quantway work out of Carnegie with Tony Breik are really brilliant, because you're taking these ideas and you're looking at them in different settings and you're constantly assessing, is it working? Well, working means, is the student learning, right? And so at my institution, we actually use the AAC and U value rubrics, and we follow students at different points. For us, the value proposition is the students can do more as a result of interacting with you. So I don't think it's an either or. An evidence-based practice, is a term that maybe just like inquiry gets loaded over time, right? But I just think we need to be curious about what we're doing and figure out what it is we want to have as the outcome, and we have to assess whether that outcome is meaningful or not. So if it's on faculty professional development, we need to assess whether the faculty are teaching more effectively. But if we just stopped there at the local level, it's over with. You may have inferred from my comment at the end about the indicators, right, that we're using effective teaching as a proxy to be that kind of dichotomy. That's not the case. I think we have to be really careful that we don't end up with what has happened in some K-12 situations where there's some assessment bar for student learning and we expect all students to get to that bar. And if they're not, then it's, the teacher's responsibility. Different students start at different points. They have different motivations. They have different goals. We have a very diverse higher education system in the US, and I think it would be disadvantageous to have some kind of national level learning test that we used for everyone. There's a lot of bias in large scale standardized tests.
Thanks, Susan. So I think we can do one more question, and we have one more question. So, and this is Chris Lorenz, and he asks or says, wonderful presentation. Thank you very much. Where might you spend more efforts to increase the number of underrepresented groups in the STEM majors in college? And it goes on a little bit, target the high school level, ? Or toward those college students who have yet to declare a major or in other majors? Or lastly, is it most efficient to spend time and resources to increase retention and graduation rates of current STEM majors?
Yeah, so this is my view with what I've seen with the data and everything over the years. I think the best bet for us is to look at our gateway courses and figure out how not to have them be gatekeeper courses. And we know how to do that, but we're not doing that in many places, right? Like even take the scale-up classrooms, Bob Buechner's work that was actually Priscilla Laws at Dickinson College and Jack Wilson RPI, and then Bob Buechner's research really spread that. You can close the gap between different groups over a single course, or you can absolutely widen it. And we're losing students from underrepresented groups at a disproportionately high level in our introductory courses. I think there's much to do after that, but if I could pick one thing right now, I would get better across the board at an inclusive introductory sciences learning course, whether it's physics or chemistry, biology, geology. And geologists are actually a neat example, right? Because geology is not typically taught in most high schools, so they're busy recruiting. Biology, we're thinking, oh my gosh, can we find enough seats and lab spaces for everyone? Geology integrates amazing field experiences. They're trying to help those first-year students understand how amazing geology is. They've done a great job at figuring out how to attract students, and now they're working really hard, and there's a joint program at NSF between the geosciences and the Division of Undergrad Education, how to change the experience for students so that you get more underrepresented groups in geology. That's a challenge. So recruiting's different for them.
So Susan, thank you so much. I think we'll end here, so we'll be on time. And to all of you still with us, we are gonna put the webinar up on our website, and I have aspirations to also share a list of some of the many wonderful resources that Susan mentioned as far as publications and manuscripts. So I encourage you to sign up for our listserv, and we'll send out a kind of reminder when all that is up, and then continue to announce future webinars. So thanks so much to all of you for joining us. And again, a virtual clap to Susan, and a big thank you for her wonderful presentation.
Thanks, everyone. Best of luck with this RCN.